Hey everyone, welcome back to our channel. Today we continue our journey into data engineering and data science within Microsoft Fabric. I'm your host Estera, and I'm delighted to introduce a new guest, Avi, who is joining us to discuss the data engineering samples starter kit for every data engineer. Avi, being a first-time guest, we are eager to learn about your expertise, insights, and also projects that you are working on. So, could you please kindly introduce yourself?
Yeah, thanks, Sarah. Well, hey everyone. I'm Abby. I'm a product manager on the Lakehouse team here at Microsoft. I've been working with this incredible team for just about 2 years now. And my role involves handling various aspects of the Lakehouse experience, such as enhancing the overall user experience and also ensuring seamless integration to our platform, Fabric.
I'm super excited for this episode because launching a new service, a new product always comes with own set of challenges. One of the most significant is how to convey the value, how to convey the story, how to build the demo, and crafting the demo that encapsulates the different capabilities of a new service is always difficult and time consuming.
So samples are incredibly valuable because they act as real life examples of how to work with data in a Spark-based environment. So think of them as like templates or blueprints that can help data professionals like you and me streamline our data processing tasks. So whether you're a seasoned data engineer, a data scientist, or just someone curious about the power of data, these samples can really be a game changer for you. They provide clear, well-documented code snippets and examples that can save you time and effort. So instead of reinventing the wheel, you can simply refer to these as these samples for guidance. It's like having an experienced mentor by your side, helping you navigate through intricacies of data processing with Spark. So I guess to summarize, samples really do offer a wealth of benefit. They can speed up your development process, improve your understanding of Spark, and just reduce the overall chances of errors in your code. So currently we have one notebook and one data set, which is a sample lakehouse in the data engineering workload. And then we have about, I think, 4 or 5 notebook samples for the data science workload as well.
Are there any prerequisites that we have to meet, provision some resources to use them?
Nothing really specific. I think if you just have a trial workspace or trial capacity enabled in your workspace, you should be good to go. Start when you click on the sample notebook, it actually creates a lakehouse as well, and it attaches it for you. It has the data already in it, so it really is a quick start for you to get started and like explore Fabric.
Great. Can't wait to see the live demo.
Yeah, let's go. Let's begin in the data engineering homepage. Upon clicking the sample tile, you will be presented with 2 types of samples to choose from. Today, we will be focusing on the notebook sample. On clicking the notebook option, a new sample notebook is immediately created in your current workspace. A lakehouse containing data we will be using in the notebook guide is also created and automatically attached to allow you to quickly get started. Now that we have an environment set up, let's walk through the data engineering starter kit. The goal of this notebook is to provide a guide which will give you a solid understanding on how to use a lakehouse as a data storage solution for analysis using Spark. Let's begin by running this notebook. In this first cell, this code loads Parquet data into a Spark data frame named df. The data is loaded from the provided file path as shown here. The display function is used to show the contents of the data frame in a tabular format. In this next step, we demonstrate how to write a Spark data frame to a Delta Lake table. Delta Lake provides a layer of reliability and performance enhancement on top of raw data in Parquet format. The write function saves the data frame as a Delta table, where the table name represents the name of the table. The Delta path represents the file path to store the Delta table. The mode function is used to specify the write mode. In this case, it is set to overwrite, which replaces any Delta table with the same name. The format function specifies the format in which the data is written, which in this case is set to the Delta format. This guide also provides you an alternate way of doing this by leveraging the integrated load-to-table experience available in the Lakehouse, which requires no Spark experience. Let's move on to the visualization of the data. Here, a Spark data frame is created by querying the delta table from the sample lakehouse. The limit clause limits the number of rows returned to 1,000. The resulting data frame is then displayed using the display function, which is a specific function that provides a convenient way to visualize data and explore it. In this next step, we show how to print out the schema of the Spark data frame. The schema defines the structure of the data. It includes the name, the data type, and as well as whether the null values are allowed or not. Another low-code integrated experience is available in the Lakehouse for schemas by opening the chevron beside the table node. Next, we demonstrate the usefulness of the show function when working with large dataset to quickly inspect the data and ensure that it has been loaded correctly. This completes part 1 of the guide. The following parts are custom advanced data engineering scenarios that you can follow along. In this first scenario, we aim to demonstrate how data engineers can perform data cleansing and filtering on a large dataset for downstream analysis. We begin by loading the data from the source and then filter out invalid records, where the trip distance and the fare amount are less than or equal to 0. Next, we cleanse the data by converting the store and forward flag column to a Boolean type, and then the pickup date time and the drop-off date time columns to timestamp types. Then finally, we write the cleansed data to the destination in the Parquet format. This scenario demonstrates the importance of data cleansing and filtering to ensure the data is accurate and valid before proceeding with further analysis. In this next scenario, we highlight how exploratory data analysis can be done on a given dataset. This is a common scenario for data engineer and is often done to identify data quality issues, anomalies, or other problems that need to be addressed before data can be used for analysis and modeling. Let's begin by leveraging the Spark data frame count function to return the number of rows in the data frame. It is a convenient way to quickly determine the size of the data frame without having to iterate over all the rows manually. However, it should be used with caution on a large dataset, as it can be a costly operation that requires significant computational resources. Then, we're using the dtype attribute of the data frame object to return a list of tuples containing the column names and their corresponding data types. Next, we're using the call function from the PySpark SQL function library to select the vendor ID column from the Spark data frame. Then we're grouping the data frames by the distinct values in the vendor ID column. The count function is then applied to the resulting group data frame to calculate the number of records in each group. Finally, the show function is used to display the resulting data frames on the console. Now, let's retrieve information about the earliest and latest pickup dates in the dataset. Here, we can leverage the min and max function from PySpark to select the earliest and latest pickup dates respectively. These dates are stored in the variable oldest day and latest day. The collect function is then used to retrieve these values and then printed to the console. We can then use the date format function to group the data frame by year, month, day of the pickup date time column and then count the number of occurrences for each date. Here, we're looking for the minimum and maximum values of the fare amount column. Then, we're performing a descriptive statistical analysis of the fare amount column by using the describe method. This computes a summary statistic including count, mean, standard deviation, minimum, and maximum. The resulting table provides insight into the central tendency and dispersion of the fare amount variable and can be useful to understand the distribution of data and identify potential outliers. Next, let's calculate the approximate quantile of the fare amount column. The function takes 3 arguments: the name of the column for which the quantile are to be computed, the list of quantile values to be returned, and a relative error value. The function returns an array of approximate quantile values for the given column and quantile values. Now, let's plot some graphs. Let's start with the histogram for the distribution of fare amount by leveraging the matplotlib library in Python. This library provides flexibility to set the number of bins for the histogram and as well as the names of the tiles and axis labels. Next, let's create a scatter plot to visualize the correlation between fare amounts and trip distance. The x and y arguments of the scatter function represents a variable to be plotted on the x and y axis respectively. The alpha argument controls the transparency of the points. The axis labels and title can also be set to your liking. In this next scenario, the data engineer wants to aggregate and summarize the data to provide insight into the overall trends and patterns in the dataset. In this example, he's calculating the average fare amount per month by grouping the data frame by year and month of the pickup date time column. He uses the average functions to calculate the average amount and names the resulting column as average fare. The resulting data frame, average fare per month, is sorted by year and month and is displayed using the display function. Finally, the code saves the results to a new delta table named average fare per month. There's one final scenario I won't be covering today, but I highly recommend you to check it out and explore it by yourself. Good luck. I 100% highly recommend everyone to check out the guide for themselves and also, especially the last scenario that I didn't get to cover during the demo. It involves like aggregating and transforming data in the preparation for machine learning modeling, which is an extremely important step of the data engineering workflow. So as it lays the foundation for the accurate and effective machine learning models, so it's definitely worth your time.
What about the runtimes? As of now, we have to runtime 1.1 based on Apache Spark 3.3 and runtime 1.2 with the new version of Apache Spark 3.4. Are our samples compatible with both versions?
Yes. So samples will work on all supported runtime by Fabric. So for any future runtimes that are coming up, we will make sure we always keep the samples updated. So it shouldn't affect you in any way.
Okay, Avi, thank you so much for being here today and sharing the demo and showing us how to use samples. Now we have almost all the resources to try it. We only need just trial capacity in Fabric to do our hands-on stuff. And that's all for today. So if you like the episode, please leave the comment, hit the like button, subscribe the channel. And until the next time, happy discovering the data engineering functionalities in Microsoft Fabric. Thank you.